In this example, we're asked to compute the limit as x goes to 0 of x plus 1 over 1 minus cos x. The first thing to do here, and really in any limit, is to just plug in whatever value x is approaching and see if the limit just falls right out. But here we plug in 0 for x, and we get 0 plus 1 is 1 up top over 1 minus 1 in the denominator. So we're doing some kind of 1 over 0 here. So this means that three things can happen, right? This can be plus infinity, this can be minus infinity, or this can be does not exist. And the way we'll view that, or the way we'll determine that, is by looking at the one-sided limits and seeing what happens with them. So we'll approach 0 from both the left and from the right. For this entire limit equaling plus infinity, our limits will look something like this, right? They'll both go off to infinity like that. For negative infinity, both the one-sided limits will go down to negative infinity. And for does not exist, the one-sided limits will go off in opposite directions. So those are the three things that can happen. When we evaluate the one-sided limits, we already know we're going to approach plus or minus infinity. So all we have to figure out is whether or not that's going to be positive infinity or negative infinity. So we're really just working with the signs here. So let's evaluate these one-sided limits. I'm going to call this whole thing f of x, just so I don't have to write it over and over again. And we have limit, and let x go to 0 from the right to begin. We'll say of f of x. Okay, so as we come in from the right, well, it doesn't really matter what happens in the numerator. That's going to be 1. And in the denominator, let's carefully look at what happens to cos x. Right, so here's a graph of cos x, and we're only really interested in what happens around 0. So here's cos x, and I'm wondering, as we come in from the right, what happens? Well, this maximum here is 1. So as we come in to 0 from the right, maybe this will be 0.9 or something like that. And actually, it's the same thing as we come into 0 from the left. Look at this. So we come into 0 from the right, we get 0.9 or 0.99, depending upon how close you want to get, 0.999, right? And from the left, we also get 0.9 or 0.99. So that's the interesting thing about cosine, is both from the left and from the right, these are going to be slightly less than 1. And you may say, wow, this isn't very exact, right? You're just going to use 0.9. Yeah, I am, because we're not going for exact numbers here or anything. All we're trying to determine is whether or not this limit is going to be positive or negative. So here I'm going to go, so we're going from the right, 1 minus 0.9. You can write 0.99 if you want, it doesn't matter. What that tells us is we're positive up here, and we're positive down here. Positive divided by positive is positive, so that tells us we're approaching positive infinity as we approach 0 from the right. As x goes to 0 from the right, y values go up to positive infinity, to be a little more exact. Okay, let's do the same thing from the left. Limit as x goes to 0 from the left of this function. Well, we already know the top, so it's 1, so that's clearly positive. And then the denominator here is 1 minus 0.9 or 0.99 again. Right, as we come in from the left, it's the same thing here. So again, that's positive. So we have positive divided by positive, positive infinity again. Since both those one-sided limits approach the same infinity, we can say that the main limit here is just x goes to 0 of f of x is itself positive infinity. For our final answer.